About a week ago, Sly Sparkane put out this video, Perspective Challenge for Flat Earthers. In it, he made a video of a round object of an unknown size and distance. He gave 3 clues, and he wanted to see if any flat earthers understood enough about perspective to give a good estimation for those dimensions. Of course, like other globers, I wanted to give this a try, and these are my revised numbers. 59.7 centimeters for the circumference based on a 19 centimeter diameter, and a ball distance of 42.1 meters. Now, I say revised because I also came up with these answers. The top one was when I first saw this, and I did a quick job of measuring and some calculations. And the ball diameter I have at 20 centimeters. Now, Sly did tell me that this was close, and later I did an imager posting. I had changed the ball diameter to 19 centimeters, but I think my new distance calculation is a little bit closer because I took a little bit more effort to make accurate measurement. But you will notice that all of my distances are within about 2 meters of each other. Now, the main reason of making this video was to show how I did this, and it was using the orthographic view in my understanding of perspective. Now, I think we all know that there is a large group within the flat earth community that say that the orthographic view, and especially the earth curvature calculator, deny perspective. Flat earthers like to use this drawing down here to understand how perspective works. So if they are correct, my calculations should be way off, but I think my calculations are going to be pretty accurate. Now, to do this, all I did was I used Microsoft PowerPoint, a Windows 10 calculator, and these orthographic views. Now, I want you to notice that these drawings are not drawn to scale. That is not important. What is important is that I model them correctly, so I know what formulas I need to do to make calculations, and it is also important that I have the correct sizes and distances. So, what was Sly's challenge? Clue 1, a round object at an unknown distance. Clue number 2, a ruler that is 128.6 centimeters from the camera. And clue number 3 is that he dollied or he moved the camera 150 centimeters to the right, and he did not change the angle or the zoom of the camera. And he just wanted the answer for 2 questions, the distance of the white ball and the circumference of the white ball. First, I want to find the circumference of the ball, and I'm going to use this clue. So the way I set this up is I have a camera. The dashed line represents the frame center, which is pointing at the wall. So when Sly moved the camera 150 centimeters to the right, that frame center on the wall should also move 150 centimeters to the right. Next, I took 2 full width cutouts of the camera in the first position and the camera in the second position. Next, I found the center of the photographs, and I noticed that this line here went right through this vent, which is located on the lower left over here. I added 2 vertical lines on each side of this vent. I copied all 3 of these lines and pasted them down here, and then aligned them so they were in the exact same position. And now I know that the distance between this line and this line should be 150 centimeters. Now, I also took a cutout of this, and I enlarged it so I could have a more accurate measurement. And then I added a ruler, and I scaled the ruler so it measured 150 centimeters between both those lines. And now I was able to accurately measure that ball at 19 centimeters. And if I multiply this times pi, I get a circumference of 59.7 centimeters. Now I need to find the distance of the ball. Next, I drew this orthographic view. So I have a 19 centimeter diameter ball at an unknown distance from a camera, and I know that the camera sees the ball with these angles. But Sly gave me one more clue. There is a ruler that is 128.6 centimeters away from that camera. So if I can find the apparent size of the ball at this distance, then I have enough information to make my calculations. So again, I took a full width cutout, I added it to the ruler, and then I wanted to make another cutout so I could make a more accurate measurement. Before I had measured this ball at about 6 millimeters, but with this larger photograph I can see it is actually a little bit smaller and closer to 5.8 millimeters or 0.58 centimeters in size. So now I have all the information I need to make a calculation, but how am I going to calculate this? I'm going to use the trigonometric formula. The tangent of the angle is equal to the opposite side divided by the adjacent side. I'm also going to use the concept called the ratio of triangles. So it's very easy to see that these three triangles have the same ratio because they share the same angle here. And of course, when I do the calculation for the tangent, it is the exact same answer, 0.35. Now all I need to do is change this so I have two right triangles that share the same angle. This is easily done by drawing a line right down the center here. And now at the ruler I have two equal segments of 0.29 centimeters, and at the ball I have two equal segments of 9.5 centimeters. Now I have two triangles, triangle A over here, and the tangent is equal to 0.29 divided by 128.6, and I have the larger triangle here, the tangent is equal to 9.5 divided by x, which is our unknown distance. And of course these share the same angle, so the tangent is the same for both of them. First I calculate the tangent of triangle A. And since I know that triangle B has the same tangent, I know that 9.5 divided by x is equal to 0.002255. I just rearrange the formula, so I'm calculating for x, and the answer is 4,212.76 centimeters. Next, I'm going to convert centimeters to meters, and since there's 100 centimeters to a meter, I just need to divide by 100. So I estimate that the ball is about 42.1 meters away from the camera. Now I can take one more step and calculate the angular size of that ball, and we can actually call this the perspective calculation, because what I'm going to determine is how big would that ball appear to be at that distance. It is a very simple calculation. All I need to do is take the arctangent of 0.002255 and I get an answer of 0.13 degrees. So I know that from 40.7 meters away, that ball will appear to be about 0.26 degrees in angular size, or just a little bit over a quarter of a degree. So again, the orthographic view does not deny perspective, because both the orthographic view and angular size calculations are based on the actual sizes and the actual distances of objects. Now, Sly hasn't released the answers yet for his challenge, but if I am wrong, then my answers should not even be close.